There are people who think about automation even with AI beneath it, and it's still about issuing static commands. Take a car, for example. Turn on the lights, honk the horn, start the car. The problem here is designing a reliable system. In this video, I'm going to show you why the system looks at what is going on and decides what to do. I'll be using this Tesla behind me as the real-life system. This is the real problem here. Command-based systems, even intelligent ones, are brittle. I've lived it. You issue an instruction and hope the environment will look and behave the way you expect. But what if the car is already unlocked? What if it's asleep? What if the network drops? What if the command partially succeeds? At that point, you're purely guessing and worse yet, assuming. And guessing at scale in enterprise or business environments is how systems and environments fail. The approach I'm using here works differently. Instead of telling the system exactly what to do, I describe what needs to be true. The system checks what's actually going on and decides whether it needs to act. If the car is unlocked, nothing happens. If it's locked, the system unlocks it. Same goal, different behavior, and there are no assumptions in this case. At a high level, the system is really just Python running on Ubuntu with an internet connection. There's a client that describes what it wants, there's a layer that checks the current state of the car, there's logic that decides whether anything actually needs to change, and there's an execution step that only runs when it has to. The loop runs every time, even when nothing changes. I'll link the full build of this on GitHub, but fair warning, setting up Tesla auth took some work, and I'm glad I only had to do it once. All right, demo number 1, the headlights. Let's start there. I'm telling the system to turn on the lights. I'm stating to the system the car should have its lights on. There is a difference between those two statements. If they're already on, nothing happens. If they're off, the system will correct it or stop the action depending on the intent. It's the same intent every time. All right, here we go. All right, demo number 2. Honk the horn. Same idea with the horn. This isn't just honk the horn. It's a signal that attention is required by the system. The system checks context, evaluates state of the car and the horn system in this case, and decides what action to take, if any. So, here we go. Okay, demo number 3. This is where we're preparing the vehicle for departure. Now, this is where it all comes together. Preparing this vehicle for departure isn't a simple and single command, but it's actually a bundle of conditions. The car should be unlocked. It should be awake. It should be at the right temperature. And I'll be sure to show this to you within the active intent logs as well. But basically, when all is said and done, the car should be ready to drive. As it's going through these activities, the system does check each one of these conditions and acts only where reality doesn't match the intent. Let me go ahead and issue the command now. There you have it. Now, why does this all matter? What you're seeing here is how modern distributed systems stay reliable. The system design allows you to reduce edge cases and avoid reactionary automation. And instead of issuing simple and static commands, you are pushing to design that converges into managing system state. Using a real car, Tesla in this particular case, improving the case for using state and intent as a part of the agentic decision-making loop. Using the AI Musabi framework that I built, I was able to get this integration in place within about 4 days of focus time. The hardest part of all of this was auth. But there are 3 main Python scripts that are driving this system. Main.py, which is the API script, auth.py, which handles OAuth, and Tesla client.py, which handles the intent and governance of the Tesla. It took a few days to define the features and the rules that I wanted this to abide by since this was my car. Then the API and the proxy communication path had to be set up to allow the platform to talk to the car and issue commands to Tesla. Getting the proper OAuth structure and all the key and rotation in place was easily about 3 days of iterative work. But All of this is on top of my repo with the documentation to explain the detailed architecture and steps to assemble this on your own if you want to take this on. Wrapping this up, state-based behavior beats command-based control because it respects the reality how things actually are. I know that's a bit of an abstract statement, but think about what happened when setting the departure on this Tesla. The system knew what the state of the car was before executing. With this, you're now really working with the system. Once you see automation in this way, it's very hard to go back in the other direction. I'll link the available Tesla API reference and the GitHub repo below if anyone wants to take a shot at standing this up themselves. For Tesla, you need to set up an account to get access to the developer information and OAuth authentication and authorization. But overall, what I just went over here is really a better way to build a system. It's really that simple. But as always, thank you very much for being here and participating within this session. Look forward to seeing you in the next video. And of course, as always, mahalo.